final session in this module that we have on the DMAIC analyze phase is going to talk about how do we assess improvement options. Now, the determination of causality for us really starts with this regression analysis and the R-squared statistic. And causality is the relationship we would like to determine. Now, we haven't really gotten to causality through this define, measure, analyze phase of statistics. What we have is apparently strong correlations between X and Y, but the reality of that may not really exist. For instance, there could be a third variable, not part of the relationship, which is causing both X and Y to vary in a manner that falsely implies a relationship between them. That might be this red X variable we've talked about. And so what we see is we are going to use the experimental design methods and the demonstration testing of the improve phase to demonstrate causality. And what that means is we're going to observe the full range of performance and understand and assure independence, which we will call orthogonality, between the factors. And what that means is when I move the X's, the Y moves in a predictable way. That's what we mean by causality. What we've done now, all we've done is establish there is a mathematical relationship between the X and the Y's. So what is causation? It's a relationship between an action and a subsequent event that it creates. The relationship between the initial action, the cause, and the subsequent action, effect, is called causality when the effect is considered to be a consequence of the cause. What we have to do is beware of this particular saying. Correlation does not imply causation. So there may be a strong one-to-one mathematical relationship between two factors, but that's not sufficient to say causality exists. A full set of conditions should be the nature of the physical experience. Are these things related to each other? The temporal sequence. The cause should precede the effect. The fact that whenever a cause is indicated, that effect actually occurs. Although that could be either deterministically, it happens all the time, or probabilistically, it happens very, very frequently as a probability. Now, causes may be either necessary or sufficient. So factor is a necessary cause if an effect cannot happen without it. In other words, if X does not happen, Y will not happen. Now, there may be other things happening, but X must be there. So that's a necessary cause. A cause is called sufficient if an effect always occurs when that preceding cause is present, so that the presence of that cause guarantees the occurrence of the effect. Thus, a logical statement for this would be, if X happens, then Y will happen. That's a deterministic effect. And when we have both of these happening together, we say it's necessary and sufficient. So for a causal condition to be necessary and sufficient, then the effect must occur if and only if that cause occurs. So Y happens if and only if X has previously happened. Now, we have to be aware. If we have the statement, if X is true, then Y is true, and then we have the second statement, Y is false, so X is false, that's the wrong argument. Because the inverse of these relationships may not actually work. This is a fault in logic called modus tollens. And what we see is in this case that when the result Y may indeed be false without causing any implications whatsoever on the condition of the X. So what we want to do is make sure that the relationship is both necessary and sufficient for us to have causation. And remember, we should check the other conditions: physical and logical relationships, sequential timing of events, elimination of all possible other effects. Now, once we've done that, we will have causation. Now, in reality, we haven't done anything yet to create the conclusion that we have created causation. So what we will do in the improve phase is we will make changes through practical examples, demonstration tests, or through scientific experimentation to observe empirical effects of the theory in the practical world. So we'll say, okay, we think, based on what we know, that if we change these particular X's, we'll get the Y. Can we demonstrate that from scratch using real-world data and say, yes, it actually happens? So that's what we're going to be doing in the improve phase. So again, we'll come back in our improve phase And we'll take a look at how do we actually make sure that the things we think are going to happen will predictably occur. So until we go back to DMAIC improve phase, I hope you're having a good day and enjoying the course.